Let's cannonball right into things. Have you had any water today? Because we're drinking water in 2020 and the subsequent years. H2O is comprised of two key ingredients: hydrogen, well, two hydrogens, recognized by Henry Cavendish in 1766, although Robert Boyle probably deserves a shout out as well, and oxygen, independently discovered by chemists from England and Sweden, Joseph Priestley and Carl Wilhelm Scheele in the early 1770s. Hydrogen is the most simple and abundant element out there, making up roughly 90% of the visible universe. It's got one proton and one electron, that's all. Oxygen is pretty important to us, but it's also a big deal to the sun, considering 0.8% of the sun's chemical makeup is oxygen. Also, apparently, pure oxygen is heavier than air. So, water. What exactly is it? Water is a common compound, most recognizable in its liquid state. Think about the oceans, your bathtub, rain, etc. It does come in other forms, such as a solid like ice or a gas like steam, which is really just oxygen or carbon dioxide. Water can't really exist as a plasma because the water boils faster than the plasma can cool, but maybe there's some Dr. Doofenshmirtz type character out there working on some plasmanator or something. I drink water literally every day, and according to the vast majority of health professionals out there, it's a good thing that I do. But why? Why do I have to drink water? I mean, water sucks. There's not even a taste really. It just kind of tastes like water. Except for Dasani. That is trash. According to Harvard EDU, Dasani is trash. Just kidding. They did not say that. According to Harvard EDU, there are 10 massively essential reasons why drinking water is one of the most crucial health conscious actions you can do for yourself. Water carries oxygen and nutrients to your cells. It aids in removing bacteria from your bladder. It helps you digest food. It helps you fight constipation. It works to balance your blood pressure. It helps stabilize your heartbeat. It provides cushioning for your joints. It protects your soft tissues and organs. It helps regulate your temperature and it lowers your sodium levels. I mean, thank you, water. I appreciate you. By the way, what are you doing later? You ever been out walking and you pass by a lake or something and you wonder to yourself, why isn't that body of water just zipping up through the atmosphere and out into space? No? Oh, well, here's the reason why anyway. The obvious answer is gravity, and I'll get to that in a second, but the atmosphere gets thinner as you increase elevation. This is because the atmosphere has to hold up the weight of all the other atmosphere on top of it, so the higher you go, the less weight has to be held up. It's like a pyramid. The top bricks don't have to hold up as many bricks. Gravity is also responsible for holding things in place on the surface of the Earth. The dense material within the planet is pulling everything towards it. Why is the apple falling towards the Earth? Newton asked. The Earth is hungry, I replied, followed by swiftly removing myself from the premises and never, ever returning. Wait a minute, I hear you cry. I thought the moon did the thing with the ocean and the thing with the tides. Yes, the moon does do a thing to our oceans, but it's a little more interesting than that. The moon also has dense material within it where all of its surface is being pulled towards, which is why, more or less, it's a sphere. The moon is massive, and that mass has an effect on the Earth, which creates a bulge on each astronomical object. And when the side of the Earth that has the moon closest to it is being influenced by its gravity, the waves are generally larger and more wild as the water is being pulled by the moon. I do also want to mention that the sun has an effect on the tides as well, but that's just a bite-sized fun fact for you. I have another hypothetical scenario for you. So, You ever been outside after a quick rainstorm where the sun comes out and an hour or so later everything is already dry? We're actually quite lucky that the sun doesn't evaporate water quicker than it already does. Earth is in a really good place in the solar system known as the Goldilocks Zone, which simply refers to a region where liquid water can exist in a solar system. If the Earth were in the position of where Venus orbits, all of our oceans would cook away, we would be bombarded with even more radiation, and we would all burn alive, dying a horribly traumatic, up, agonizing death. Isn't space fun? Okay, we cannot scooch any closer. It's just too hot. So let's move Earth farther out, say to the orbit of Mars. Now what? I'm sorry to say, it's still not looking great. Our oceans would freeze, and we most likely wouldn't fare much better, but at least our odds of survival are slightly increased. We could utilize geothermal heating and vertical farming, but our livestock and pollinators would generally have a difficult time adapting. RIP. Often, the Earth is referred to as the blue marble, and that's a fair observation to make. I mean, the surface is covered by over 70% water, and over 90% of that is contained in our oceans. Of all that water, only 3% is fresh, but only 0.5% is drinkable. I'm sure that sounds concerning, and maybe it is, but I'm obviously not an expert on water. Anyway, just look at this thing. There's no way you look at this and miss how extraordinarily blue it is. Unless you're blue colorblind, I guess, in which case here's a picture of a sad puppy because I cannot appropriately operate in awkward situations. But yeah, there's a lot of water here. Or at least that's what the water truthers want you to believe. But when did it all show up, and how did it get here? Uber Eats wasn't founded until 2014, so that couldn't have been it. In the early solar system, like when it was no more than a protoplanetary disk, which is a swirling cloud of ice and rock orbiting a newborn star, which is where all the planets and asteroids originate from. The rocks and ice collided into clumps called planetesimals, and as the clumps got bigger, they attracted more debris and eventually became the planets and moons, plus all the other objects that we still have kicking around to this day, billions of years later. Even though there was most likely water present in the form of icy rocks during the formation of our solar system, the planetesimals and other prime targets for collision were in a constant state of ouch, this is actually so hot, oh my god. And if you know anything about ice when it comes into contact with molten heat, you'd understand why the water wasn't in a great position to sit down and set up shop on the early terrestrial bodies. If we want the water to stick around, we have to crank down the heat. Over time, the amount of abuse the early Earth was hit with slowed down as the largest planetesimals began to attract the majority of the fragments. In other words, this was a perfect time for something like a comet or a large body with icy material to bring us some of that sweet, watery nectar. One study published in the journal Science actually suggests that an object similar to that of Vesta, one of the largest objects in the asteroid belt, may have been responsible for gifting our world water. A similar body to Vesta is Ceres, which is the largest object between Mars and Jupiter. It may have also played a supporting role in the Earth's early years. There isn't too much of an issue if you were to combine these theories into one, believing that a large object in the early solar system delivered the Earth icy material as well as asteroids and comets. Regardless, the water had to get here somehow, and that's the best we have so far. We've been studying protoplanetary disks encircling other stars more and more. So the data we are on the verge of collecting will most likely be a huge aid in learning more about the formation of rocky planets like Earth, as well as gas giants in each of their specific types. Tel Aviv University and Harvard University published their findings about water in the early universe, which suggests when at around 5% of its current age, the first water was beginning to form. If water universally plays a role in the formation of life as it happened on Earth, given how long water has been around, this could mean that life has had a lot longer to develop than we may have originally thought. By the way, 5% of the universe's age is about half a billion years, and we're at like 13-ish billion right now. Are there any objects in the solar system that might be worth checking out if we want to explore the role water plays here? Well, yeah, there's actually a decent handful. Like I said before, the dwarf planet Ceres has ice on it. The moons Ganymede, Europa, and Callisto of Jupiter have a good possibility of containing oceans beneath their surfaces. The moons Enceladus and Titan of Saturn might have subsurface oceans. There's water ice permanently stored in certain craters of Mercury, and it is widely believed at this point that in the distant past, Mars definitely had oceans. Though there are many options, researchers are the most excited about Enceladus and Europa. This is because not only do these moons possibly have extremely deep oceans beneath their icy and rocky surfaces, but the ocean floors are hypothesized to be minerally rich and have important chemicals that are necessary to originate life as we know it. Does this mean that there's guaranteed to be life on these distant worlds? Unfortunately not, but no need to get discouraged. There's a lot of missions happening in the upcoming decades that I'm sure will put a smile on your face, but this video is already too long, so let's just focus on the water aspect for right now. The ocean floors of these moons could house hydrothermal vents, and if you know anything about vents on the ocean floor, it's that they are boiling hot with chemicals that could probably ruin my day if I came into contact with them. But in the case of our planet, hydrothermal vents are like biological lighthouses. The immediate regions surrounding vents on the ocean floor are more often than not teeming with life, as creatures of all sorts use the chemically invaluable vents for their own benefits. It's easy to talk about journeying hundreds of millions and, in some cases, billions of miles to explore the outermost points of interest in our solar neighborhood, but there's also one place much closer to home where we can find off-world ice: the moon. There are spots in some craters at the poles of our moon that rarely, if ever, receive direct sunlight, but the southern pole has much more water ice than the northern one. I mean, the temperature in this environment never reaches above negative 250 degrees Fahrenheit, negative 157 Celsius. Anyway, let's say we've already taken a good look at all the astronomical bodies in our solar system, but no luck. Now what? Is all hope lost in the search for life? Are we truly doomed to be alone, destined to aimlessly fill in the gaps with our own civilization forever? Man, you're kinda bumming me out, I'm not gonna lie. There's already ongoing missions, and there are more planned for the future with the intent of hunting for exoplanets of all kinds, both potentially habitable and downright absurdly dangerous. Just so we're on the same page, an exoplanet is simply a planet that orbits another star. I bet you can guess what an exomoon is. Go ahead, I'll give you a minute. In regards to water, there are no doubt countless worlds with subsurface oceans, as well as enough water worlds to make your head spin. One of the most common exoplanets discovered by the Kepler, K2, and TESS missions are super-Earths, which are terrestrial exoplanets slightly larger than our home. Some astronomers believe that many of these super-Earths may be entirely covered in liquid oceans. In the near future, the James Webb Space Telescope will blow the current planet finders out of the water. You may be familiar with the Earth and its oceans, but did you know that this planet may also have subsurface oceans? Or at least it maybe does. Basically, we found this material called crystalline carbon which exists between the upper and lower mantle in a place called the transition zone. Atoms of both hydrogen and oxygen were discovered embedded into the crystal structure of the mineral, and if you've been paying attention today, you'd know that hydrogen and oxygen are components of water. For further evidence that the Earth may contain a subsurface ocean, diamonds were discovered that came from the mantle which actually had liquid water trapped inside them. These discoveries don't exactly prove that massive ocean pockets linger miles beneath us, but it does raise some questions that certainly deserve answers. Unfortunately, it's not super easy to get to the mantle right now, or ever, but if that research goes anywhere, I'm sure I'll hear about it, and then I'll tell you after I inevitably end up disappearing for another 6 months again. Most of us take the Earth's oceans for granted, but they probably won't be here forever, especially if climate change continues to pump endless amounts of greenhouse gases into the atmosphere. We may not be directly responsible for the departure and evaporation of our oceans, but we should still feel compelled to treat the planet better. Anyway, tangent over. As the sun gets older, it grows brighter, and the solar radiation will absolutely cripple our planet. The water on the Earth will evaporate faster, creating more water vapor, which is a greenhouse gas, which traps more heat, and the runaway greenhouse effect takes over, and this repeats unchallenged until it's game over. Once things start to pick up with the sun, how long do we actually have to move to another world or to find a solution to the sun's negative effects on the planet? Well, the soonest researchers are estimating is that by about 500 million years from now, there won't be much water at all left, and I don't think the animals that call the blue marble home will be too happy to find out that they have to adapt to a gray and brown one. Based on what I've read, it seems like the longest we may have to leave the planet is about 1 billion years, but this could change in the upcoming decades, given that we're learning more about our solar system each and every day, but hey, at least you and I won't have to worry about it. Anyway, I'm gonna get a glass of water and start editing this. Thank you all so much for watching, and please stay safe. Let me know if there's a topic you'd like to see me cover in an upcoming video, and the links to my sources can be found in the description below. Short and simple topics? Alright, I'm done. Goodbye.